The silence of the solar system was absolute. It was not an empty silence, but a heavy waiting kind of quiet that had existed for billions of years. On October the 3rd, 2025, the planet Mars hung in the black velvet of space, a lonely sphere of rusted iron and frozen dust. From a distance it looked peaceful. The thin atmosphere clung to the surface, a delicate veil of pink and ochre against the infinite darkness. There was no wind that a human ear could hear, only the silent, endless drift of cosmic dust and the cold light of the distant sun. For weeks, astronomers on Earth had been watching a new visitor entering this quiet neighborhood. They called it 3I Atlas. It was a comet, or perhaps an asteroid that had traveled from deep interstellar space. It was a wanderer from another star system just passing through ours. To the telescopes, it looked like nothing more than a jagged, tumbling mountain of dark ice and rock. It was roughly 2 kilometers long, shaped like a splinter of bone. It was cold, dead, and silent. It had been traveling for millions of years, a ghost moving through the void. The prediction said that Atlas would pass very close to Mars. It was a rare event, a cosmic near-miss. The gravity of the red planet would pull on the object, bending its path slightly, before slinging it back out toward the edge of the solar system, never to return. It was supposed to be a routine observation, a chance to study the chemical makeup of a rock from another world. Dr. Sarah Chen sat in the control room of the Deep Space Network station in the high desert of California. The room was dim-lit only by the cool blue glow of 24 monitors. Outside, the giant white dishes of the antennas were pointed at the sky, listening to the faint whispers of the universe. It was 3 in the morning, and the coffee in her mug had gone cold hours ago. Sarah rubbed her eyes. She had been tracking Atlas for 3 months. She knew its orbit, its speed, and its rotation better than she knew the layout of her own apartment. To her and to the rest of the scientific community, Atlas was just a dirty snowball. It was interesting because of where it came from, not because of what it was. Approaching periapsis, she whispered to herself. This was the point where Atlas would be closest to Mars. On the main screen, a simulation showed the path of the object. A green line traced the trajectory of Atlas as it grazed the gravitational field of Mars. Data streams flowed down the side of the screen, columns of numbers representing speed, distance, and temperature. Everything was normal. The object was behaving exactly as Isaac Newton's laws of physics said it should. It was a dead rock falling through gravity. Then the first anomaly appeared. It started as a small flicker on the thermal sensor. The temperature of Atlas, which had been close to absolute zero, suddenly spiked. It wasn't the slow warming that happens when sunlight hits ice. This was sudden, sharp, and internal. Sarah leaned forward, her chair creaking in the quiet room. She typed a command to refresh the sensor feed. Must be a sensor glitch, she muttered. Calibration error. But the numbers didn't go back down. They climbed higher. Out in the void, 55 million kilometers away, the dark shape of Atlas was changing. As it crossed the invisible line of its closest approach to Mars, the ice on its surface began to shift. It didn't crack or break apart like a natural comet. Instead, the outer layer seemed to shimmer. The dark, crusty surface that had absorbed the light of the stars for eons began to vibrate. The vibration was not mechanical, it was electromagnetic. Back on Earth, the alarms on Sarah's console began to chirp soft warnings. The radio telescope was picking up a signal. It wasn't the random hiss of static that usually comes from celestial bodies. It was a tone, a structured rhythmic pulse. Sarah froze. Her heart hammered against her ribs. She looked at the spectral analysis window, the tool that tells scientists what an object is made of by analysing light. Usually this window showed simple lines indicating water, carbon, or iron. Now the screen was a chaotic storm of colours. The reading wasn't showing chemical elements anymore. It was showing pure energy. "What are you?" Sarah breathed. The telemetry showed that Atlas was slowing down. This was impossible. An object in freefall cannot just decide to hit the brakes. To slow down in space, you need thrust. You need an engine. You need intent. The dead rock was decelerating at a rate of 400 meters per second squared. The gravitational pull of Mars, which should have dragged it in or flung it away, was being countered by a force that the sensors couldn't identify. On the visual feed, which was being relayed from a satellite orbiting Mars, the image of Atlas cleared up. The jagged, bone-like shape was gone. The outer shell of ancient dust and ice had vaporized in a flash of silent light, revealing what was hidden beneath. It was no longer a rock, it was a structure. It was a perfect smooth cylinder, blacker than the space around it, absorbing all light except for a faint pulsing vein of blue luminescence running down its side. It looked like a needle threading the sky. The surface was not scarred by craters or erosion. It was mathematically perfect. The energy readings on Sarah's screen went off the charts. The object wasn't just glowing, it was singing, it was broadcasting a signal so powerful that it drowned out the background noise of the entire galaxy. Sarah's hands shook as she reached for the phone to call the director. She hesitated. Her mind struggled to process what her eyes were seeing. A lifetime of education of learning about the barren, lonely nature of the universe was being rewritten in seconds. She looked at the data again. The electromagnetic field around the object was expanding. It reached out like invisible fingers brushing against the magnetic field of Mars. The interaction created a brilliant aurora in the Martian atmosphere, a sudden storm of green and violet lights dancing over the rusty red dunes, visible even from the satellite cameras. The object had woken up. It wasn't a visitor passing through. It wasn't a passive traveller. It had arrived at a destination. The signal changed pitch. It shifted from a chaotic burst of noise into a repeating sequence. It wasn't binary code and it wasn't analog static. It looked like a waveform complex and beautiful, resembling the vitals of a living thing. Sarah realised she was holding her breath. The control room felt too small, the air too thin. She felt a sudden overwhelming sense of vertigo, a feeling of being very small standing on the edge of a very deep canyon. The universe had suddenly become much larger and much more crowded. She hit the record button on the main console, ensuring every bit of this impossible data was saved. Then she typed a single log entry into the system, her fingers trembling over the keys. Subject 3I Atlas, status active, nature artificial. She stared at the screen at the smooth black cylinder hanging above Mars, pulsing with a light that was not of this world. The silence of the solar system was broken. The long wait was over. Sarah picked up the phone. Her voice was steady, but it felt like it belonged to someone else. "Director," she said into the receiver, "you need to wake everyone up. We are not alone." In the frozen silence above the red planet, the Guardians were waiting. They were not made of flesh and bone, but of titanium gold foil and silicon. They were the sentinels of humanity eyes thrown across the void to watch over a world that was not our own. High in the thin, cold atmosphere, the Mars Express drifted. It was the elder statesman of this group, a traveller from the European Space Agency that had been circling Mars for nearly 2 decades. Its joints were stiff, its heaters working hard against the bitter cold of space, but its electronic heartbeat with a steady, reliable rhythm. It remembered the silence of the early years, but now it was not alone. Nearby, circling in a different orbital path, moved the Mars Reconnaissance Orbiter, or MRO. It was the sharp-eyed American scout carrying a camera, so powerful it could spot a dinner table on the surface from hundreds of kilometers away. Just above the horizon floated the Trace Gas Orbiter, a joint creation of Europe and Russia, sniffing the thin air for the chemical sense of life, and diving lower, skimming the edges of the atmosphere, was Maven, the NASA hunter designed to taste the solar wind. They were machines from different nations built by people who spoke different languages and lived under different flags. But out here in the black velvet of space, there were no borders. There was only the mission. There was only the data. When they spoke to each other, they did not use English or Russian. They spoke in the universal language of binary code, a stream of ones and zeros that created a perfect silent harmony. Then it happened. It did not begin with a sound, for sound cannot travel in a vacuum. It began as a ripple in the invisible fabric of energy that surrounds the planet. The sun, that distant burning star, had hurled a massive storm of particles toward Mars. In the vastness of space, this solar wind usually washed over the planet like a gentle stream. But this time the stream became a tsunami. A shockwave of pure energy slammed into the magnetic environment of Mars. To a human, this moment would have been invisible, but to the Sentinels it was blindingly bright. It started with Maven. Its sensitive instruments designed to detect the magnetic personality of the planet screamed a warning. The numbers on its internal processors spiked. The magnetic pressure around Mars did not just rise, it tripled in the blink of an eye. At the exact same moment, the Trace Gas Orbiter felt the impact. Its sensors, usually looking for delicate traces of methane, were suddenly flooded with high-energy electrons. This was the beginning of the chorus. If you could hear radio waves, if you could translate the data streams into sound, it would have sounded like a sudden, sharp inhale of breath followed by a chaotic, beautiful symphony. The 4 spacecraft were reacting faster than any human thought began to record. They did not panic. They did not feel fear. They simply opened their electronic eyes wider. For exactly 7.3 seconds, the space around Mars convulsed. 7.3 seconds is a short time for a human. It is a breath, a heartbeat, glance at a watch. But for a computer, 7.3 seconds is an eternity. In that stretched-out moment, the Sentinels captured a phenomenon never before seen in such detail. The magnetic protection of Mars, which is usually messy and weak compared to Earth, suddenly collapsed and then reorganized. The solar wind compressed the planet's magnetic bubble until it was almost touching the atmosphere. And then the lights turned on. On Earth, auroras, the northern lights, are confined to the poles dancing in green and purple ribbons near the Arctic and Antarctic. This is because Earth has a strong magnetic shield that guides the solar energy to the top and bottom of the world. But Mars has no such shield. Mars is naked to the stars. Because there was no shield to guide the particles, the solar storm did not just hit the poles, it hit everywhere. The data from Mars Express and MAVEN painted a picture of breathtaking beauty. The entire planet from the North Pole to the south, from the morning side to the evening side, lit up. It was a global aurora. If a human had been floating there looking down with special ultraviolet glasses, they would have seen the red planet suddenly engulfed in a glowing, ghostly halo. It was like a Christmas tree lighting up in a dark room. The atmosphere glowed with ultraviolet light as the solar particles smashed into the hydrogen and oxygen atoms high above the surface. The trace gas orbiter recorded the energetic particles raining down, measuring their speed and intensity. MRO watched how the atmosphere below swelled and heated up in response. Mars Express watched the electrons dance. They were 4 distinct machines looking at the same event from 4 different angles. Mars Express saw the depth of the electron rain. MAVEN saw the magnetic collapse. The trace gas orbiter tasted the energy change. MRO saw the atmospheric reaction. Together, their data streams merged. It was a song of discovery. Alone, one spacecraft might have thought its sensors were broken. Alone, they might have missed the full picture. But together, they validated each other. They confirmed that this was real. They sang a song of confirmation. "I see the spike," sang MAVEN. "I feel the heat," answered MRO. "I measure the light," added Mars Express. This chorus of data travelled across millions of kilometres of empty space. It moved at the speed of light, racing back toward the small blue dot called Earth. It carried with it a story of a planet under siege by its own sun and the beautiful violent light show that resulted. There was a profound beauty in this mechanical coordination. These machines were thousands of kilometres apart, moving at thousands of kilometres per hour, yet they acted as a single organism. They were the senses of humanity extended into the dark. They felt the solar wind so that we wouldn't have to. They watched the invisible light so that we could understand it. As the 7.3 seconds ended, the magnetic pulse faded. The solar wave passed. The global aurora dimmed, returning the planet to its usual darkness. The energy levels dropped. The processors cooled down. The Sentinels returned to their silent vigil. Mars Express adjusted its solar panels. MAVEN dipped back into its lower orbit. MRO pointed its camera back at the dusty surface. They did not know they had just made history. They did not know that scientists back on Earth would spend years analysing those 7.3 seconds, marvelling at the Christmas lights of Mars. They did not feel pride, but in that brief moment as they faced the unknown together, they were more than just metal and wire. They were a testament to the human spirit, the part of us that refuses to stay on the ground, the part of us that builds ships to sail the sea of stars, and the part of us that listens to the universe waiting for it to sing back. The chorus ended, but the data remained a permanent record of the day the sun touched Mars, and the Sentinels were there to watch it happen. The silence in the control room at the Mauna Kea Observatory was heavy, thicker than the mountain air outside. Usually these rooms were filled with the low hum of cooling fans and the rhythmic clicking of keyboards, but tonight the atmosphere was different. It was the silence of people holding their breath, waiting for a hammer to fall. On the main screen, a large digital simulation displayed the solar system. A bright yellow circle represented the sun. A thin, calculated green line showed the predicted path of 3i Atlas. This green line was based on centuries of astronomical knowledge. It was based on the laws of Johannes Kepler and Isaac Newton. It was the mathematical certainty that governed the movement of planets, moons, and stars. According to the math, the object should swing around the sun and be flung back out into the darkness like a stone thrown from a sling. Dr. Michael Harrison stood with his arms crossed, his eyes fixed on the telemetry data streaming in from the network of space telescopes. He was a man who trusted numbers. Numbers did not lie. Numbers did not have agendas. "Time to perihelion minus 2 minutes, a technician announced quietly. Perihelion was the point where the object would be closest to the sun, the moment of maximum gravitational stress. "Velocity is consistent," Michael muttered, though his brow was furrowed. 110 kilometers per second. It is moving fast. Dr. Rachel Morrison sat at the main terminal, her fingers hovering over the keys. She wasn't looking at the speed, she was looking at the vector, the direction. "Michael," she said, her voice trembling slightly, "look at the lateral shift, it's drifting." "It's not drifting," Michael dismissed, though he leaned closer to her screen. "It's likely just sensor noise. The radiation from the sun is interfering with the signal." "It is not noise," Rachel insisted. "Watch." As 3i Atlas approached the sun, the simulation updated in real time. A red line appeared on the screen overlaying the predicted green line. The red line represented reality. At first, the two lines were identical, but as the object reached its closest point to the star, they began to separate. The green line curved smoothly following the natural bend of gravity. The red line, however, did something impossible. It straightened. "It's shallowing its orbit." Michael whispered, the colour draining from his face. "That's not possible. Physics doesn't allow that." To understand why Michael was terrified, one must understand the simple, unbreakable rules of orbital mechanics. Imagine a giant invisible bowl with the sun at the bottom. When an object like a comet or an asteroid enters the solar system, it is like rolling a marble into that bowl. The marble rolls down the side, picking up speed as it falls toward the bottom, the sun. As it whips around the bottom and starts to climb up the other side, gravity, the shape of the bowl, naturally slows it down. The exchange is perfect. Energy is borrowed and energy is returned. The object cannot just decide to change its path. It is a prisoner of gravity. But 3i Atlas was not behaving like a marble. It was behaving like a surfer. "Accretion of speed is increasing," the technician called out, his voice rising in panic. "It is not slowing down as it exits the solar well. It is accelerating. Repeat, the object is accelerating." Michael grabbed the desk. "Is it outgassing? Is it a comet?" This was the only logical explanation. Comets are dirty snowballs. When they get close to the sun, the ice heats up and shoots out jets of gas. These jets act like tiny rocket thrusters, pushing the comet slightly off course. It is a known phenomenon called non-gravitational acceleration. "I am scanning for a tail," Rachel said, typing furiously. "Searching for hydrogen, water vapor dust, anything." The screen flashed a stark negative result. "Zero coma," Rachel said, her voice hollow. "No gas, no dust, no tail. It is a solid block of metal and rock. It has no natural propulsion." Yet the numbers on the screen were screaming the truth. 3i Atlas was leaving the sun travelling faster than it had arrived. It had gained velocity. Specifically, it had gained about 0.01 kilometers per second squared of acceleration that could not be explained by the sun's gravity. In the world of astrophysics, that number was massive. It was the difference between a rock falling and a bird flying. "It is defying Newton," Michael said, taking off his glasses and rubbing his eyes. "An object in motion stays in motion unless acted upon by a force. Gravity is the only force out there, but gravity pulls things in. This thing's pushing itself out." Rachel stared at the red line on the screen. The deviation was elegant. It wasn't tumbling or chaotic. The object had adjusted its trajectory by a fraction of a degree, just enough to slingshot it toward Earth's orbital path rather than into empty space. "It's not a mistake, Michael," Rachel said softly. "It is a maneuver." The word hung in the air, maneuver. Rocks do not maneuver. Rachel pulled up a visualization of the forces at play. "Think of it like a car on a highway," she explained mostly to herself, trying to process the impossible. "If you take your foot off the gas pedal and coast down a hill, gravity pulls you down. When you go up the next hill, you slow down. That is what a rock does. But Atlas just pressed the accelerator while going uphill. It pushed against the gravity of the sun." "But where is the energy coming from?" Michael demanded, his scientific worldview fracturing. "There is no engine, no heat signature, no exhaust plume. You cannot just create energy out of nothing. It violates the laws of thermodynamics. Maybe it uses a physics we do not understand," Rachel suggested. "Or maybe it is a solar sail utilizing the pressure of light itself." Michael shook his head violently. "A solar sail needs to be thin, massive and reflective. This is a dark cigar-shaped cylinder. It makes no sense." They watched in helpless silence as the object completed its turn. It was a display of control that was both beautiful and terrifying. The sun, the most massive and powerful object in the solar system, the gravitational anchor that held Jupiter and Saturn in place, had tried to grab 3i Atlas. And 3i Atlas had simply said no. It had treated the sun not as a master, but as a tool, a gravitational post to grab onto and swing around to change direction. "The new trajectory," the technician said, his voice barely a whisper. "Where does it go?" Rachel ran the calculation. The red line extended out from the sun, crossing the emptiness of space, intersecting directly with the path of the third planet. "It is correcting course," Rachel said, a chill running down her spine that had nothing to do with the air conditioning. It is not just passing through Michael. It adjusted its speed to match the orbital plane of Earth. It wants to get a better look at us. The sense of scale in the room shifted. For decades, humans had looked up at the stars, feeling safe in their isolation, believing that the vast distances of space protected them. They believed that the laws of physics were a wall that kept the monsters away. But now, looking at that red line deviating from the green, they realized how small they were. They were watching a visitor that could ignore the gravity of a star. They were watching a traveler that did not need fuel, or at least not fuel that humans could see. "We are like ants," Michael whispered, finally accepting the data. "We are ants watching a highway engineer build a road, trying to understand why the ground is shaking." The Object 3I Atlas sped away from the sun, silent and dark. It had broken the rules, it had ignored the heavy hand of gravity, and now, with a slight calculated increase in velocity, it was turning its sensors toward the quiet blue planet waiting in the dark. The containment chamber was bathed in a light that did not belong in a basement laboratory. It was not the sterile white of the overhead LEDs, nor the urgent red of the warning strobes. It was a violent, shifting violet that seemed to vibrate the air itself. Inside the reinforced glass cylinder, the object was no longer just a silent artifact. It had awakened. Dr. Elena Vasquez stood behind the 3-inch thick leaded glass. Her hand pressed against the cool surface, though she felt phantom heat radiating through it. She watched the air immediately surrounding the artifact transform. It was happening fast. The gas molecules in the chamber were being ripped apart, stripped of their electrons and turning into plasma. It looked like a halo of electric fluid dancing and swirling in a rhythm that felt almost alive. "Status report," Elena whispered, though her eyes never left the violet glow. "Temperature at the surface is spiking, Doctor." A technician called out, his voice trembling slightly. "We are reading 3 million degrees Kelvin and rising." Elena nodded slowly. 3 million degrees. That was hot enough to melt any metal on Earth instantly. Yet the object itself remained perfectly solid. It sat there dark and composed while the air around it burned with the fury of a small star. This brought them to the first impossibility, the mass-energy paradox. According to everything physics had taught humanity for the last century, energy and mass were two sides of the same coin. The famous equation energy equals mass times the speed of light squared dictated the rules. To generate the kind of energy they were seeing, terawatts of power enough to light up the entire eastern seaboard, you needed fuel, you needed mass to burn. But the object was tiny. It was no larger than a grapefruit. It had not lost a single microgram of weight since the reaction started. "It defies thermodynamics," Elena muttered to herself, pulling up the energy output graphs on her tablet. The lines were shooting vertical. A source this small should burn itself out in a fraction of a second. It should explode instead. It is breathing. She looked at the numbers again. The energy density was astronomical. If a battery the size of a phone held this much power, it would be heavier than an aircraft carrier. Yet she could lift this object with one hand. It was a contradiction that made her head spin. It suggested that the object wasn't just storing energy, it was pulling it from somewhere else, or perhaps it was creating it continuously through a process that made nuclear fission look like a damp matchstick. "Doctor, look at the magnetic readings," the technician said, his voice pitching up. "The field lines, they aren't looping." Elena swiped her screen to the magnetic topology view. What she saw made her breath hitch in her throat. In a standard fusion reactor like the massive tokamaks humans built, we use giant magnets to squeeze plasma into a donut shape. It is messy, difficult, and unstable. It is like trying to hold jelly together with rubber bands. If one magnet fails, the hot plasma touches the walls and everything melts. The object, however, was generating its own magnetic field, but it was a structure Dr. Vasquez had never seen, not even in theoretical simulations. Shutterstock. The field lines did not just loop from north to south, they twisted back on themselves, folding over and over in a complex non-Euclidean knot. It was a self-contained bottle. The superheated plasma was trapped inside this invisible cage, flowing in perfect silence. It never touched the surface of the object. The heat they were measuring was just the tiny amount of radiation escaping the trap. "It is a perfect bottle," Elena said, her voice filled with a terrified awe. "Look at the geometry. It is a triple-twisted torus. It keeps the plasma stable without any external power. It is self-sustaining." She realized she was looking at the fire of creation. Inside of that violet halo, hydrogen atoms, or perhaps something more exotic, were smashing into each other. They were overcoming the electric force that pushes them apart and fusing together. Fusion. It was the process that powered the sun. It was the engine of the universe. Every time two atoms fused in that halo, a tiny bit of mass was lost and converted into a burst of pure energy. A photon of light was born, travelling outward to hit the sensors. Eleanor stepped back, overwhelmed by the philosophical weight of what she was seeing. "Do you realise what this is?" she asked the room, though nobody answered. She looked at the glowing heart of the chamber. In the cold, dark emptiness of space, gravity pulls dust and gas together until the pressure becomes so high that fusion ignites. That is how a star is born. Stars are the furnaces of the cosmos. They take simple dust and cook it until it becomes heavy elements: carbon, oxygen, iron. The very things that make up the human blood and bones were forged in the centre of a star that died billions of years ago. And now that same holy fire was burning inside a basement lab, held in place by a magnetic knot that shouldn't exist. "It is beautiful," she whispered. The light shifted from violet to a blinding blue-white. The hum of the containment field grew louder, a deep vibration that rattled Elena's teeth. The object was simulating the core of a sun. It was a pocket-sized stellar nursery. But there was a danger here too. A star is a balance between gravity pulling in and radiation pushing out. If that balance breaks, you get a supernova. "Dr. Vasquez," the technician warned, "the magnetic field is expanding. It is pushing against our containment. The structure, it is unfolding." Elena watched the screen. The impossible knot was loosening. The fire of creation was asking for more room to burn. The paradox of its size was becoming a threat. If that magnetic bottle opened even for a microsecond, the heat of a sun would be unleashed in a room made of concrete and steel. "Hold the line," Elena ordered, her eyes reflecting the blue-white fire. "Don't shut it down. We have to see how the cycle ends. We are watching a star breathe." She watched the plasma swirl, hypnotized by the raw power. It was the ultimate to promise infinite energy, free and clean. But it was also the ultimate weapon. For a moment, standing before the glare, Elena felt small. She felt like early man staring at the first spark of fire, wondering if it would warm them or consume them entirely. The light grew brighter still, turning the room into a landscape of stark white shadows, and the fire of creation roared in silence. The laboratory was never truly silent. Even at 3 a.m, the air hummed with the sound of cooling fans, the rhythmic beeping of monitors, and the low electric buzz of the containment field. In the centre of the room, suspended inside a glass cylinder reinforced with magnetic coils, the artifact floated. Dr. Rachel Torres sat in front of a wall of screens, her face bathed in the blue glow of data streams. She had not slept in 20 hours. She barely blinked. Her coffee had gone cold hours ago, but she didn't notice. She was staring at a miracle, trying to force it into the boxes of physics she had spent her life memorizing. To the naked eye, the artifact looked like a jagged piece of obsidian, dark and glass-like. But under the sensors, it was a screaming storm of energy. It was not just a rock. It was a machine, or perhaps an organ belonging to something much larger. Rachel rubbed her tired eyes and leaned into the microphone to record her log. Her voice was raspy but steady. "Log entry 742, subject structure analysis. We are no longer looking for a battery. A battery holds a charge. This thing does not hold energy. It breathes it." She tapped a key, bringing up a holographic model of the artifact's surface structure. This was her first hypothesis: metamaterials. In the world of human engineering, metamaterials were artificial structures designed to do things nature could not like, bending light to make an object invisible. Rachel zoomed in on the hologram. The image magnified the surface of the artifact 1 billion times. "The lattice structure is impossible," she whispered to the empty room. "Usually atoms line up in neat rows like soldiers, but here the atoms were arranged in a spiral pattern that seemed to go on forever. It was a fractal, a shape that looked the same no matter how close you zoomed in. It trapped light waves, spun them around, and released them as pure heat. It acted like a lens, but not for light. It was focusing the fabric of space itself. "It is a supermaterial," she noted, typing the words onto the screen. "It has a negative refractive index. If I shine a light on it, the light does not bounce off. The light flows around it like water around a stone. This is why it looks so dark. It is not absorbing the light, it is guiding it somewhere else." But where? She moved to the next set of data, the composition. This was where the fear began to creep in. When they first weighed the object, the scales broke. It was heavy, incredibly heavy, yet it floated in the magnetic field as if it weighed nothing. Rachel pulled up the particle analysis. The screen showed a chaotic dance of colours, red, blue and green dots swirling together. "Standard matter is made of up quarks and down quarks," Rachel mumbled, reciting the basics to keep herself grounded. "Protons and neutrons, that is what makes up a star and me." She looked at the reading. The artifact contained something else. Strange quarks, she said, the word tasting like metal in her mouth. This is strange matter. In theoretical physics, strange matter is a soup of particles that is perfectly stable but denser than the core of a neutron star. There was a theory that if strange matter touched normal matter, it would convert everything it touched into more strange matter. It would be a contagion, turning the Earth into a hot, dense ball of goo. Rachel's hand hovered over the emergency shut-off button. She had panicked when she first saw the reading, but the artifact was not eating the lab. It was stable. It was contained. It defies the Pauli exclusion principle, as she recorded. The particles are packed so tightly they should be crushing each other, but they are not. It is perfect harmony. It is heavy enough to bend gravity, yet it generates a localized anti-gravity field to keep itself buoyant. It is a paradox wrapped in a shell. She leaned back, spinning her chair to look directly at the artifact. It pulsed with a faint violet rhythm. "You aren't from here, are you?" she asked it softly. Finally, she arrived at the most impossible part, vacuum energy. Rachel pulled up the energy output graph. It was a flat line at the very top of the chart. For 3 days, the artifact had been outputting enough gigawatts to power the entire city without losing a single gram of mass. "Energy equals mass times the speed of light squared," she quoted Einstein. To get energy, you have to burn mass. You have to lose something to get something. That is the law of the universe. You cannot get a free lunch. The artifact was getting a free lunch. She opened the simulation for 0-point energy. In quantum physics, empty space is not actually empty. It is seething with invisible waves, particles appearing and disappearing in a fraction of a second, 10 to the power of -21 seconds. This is the background hum of the universe. It is a valve, Rachel realized, her eyes widening. The fractal structure, the metamaterial and the density, the strange matter were working together to create a puncture. The artifact wasn't creating energy. It was reaching into the vacuum of empty space and pulling the background energy out. It was tapping into the heartbeat of the cosmos. Rachel stood up and walked to the glass wall of the containment chamber. She placed her hand against the cold glass. On the other side, the object hovered. This was the answer to the energy crisis. It was the end of fossil fuels. It was the end of scarcity. But it was also terrifying. If this is a valve, she thought, who built the pipe? And what happens if we open it too wide? The numbers on the screen began to climb again. The output was increasing. The violet light grew brighter, illuminating the dark corners of the lab. It wasn't just radiating heat anymore. It was radiating a feeling. Rachel felt a vibration in her teeth, a hum in her bones. It wasn't sound. It was pure presence. She looked at her notes. Metamaterials, strange matter, vacuum energy. These were just words humans invented to label things they barely understood. They were maps for a territory no one had ever visited. "It's not just physics," Rachel whispered, a shiver running down her spine. "It's architecture. Someone had built this. Someone had woven quarks together like threads in a blanket. Someone had engineered a door into the vacuum." For the first time in her career, the line between scientist and believer blurred. She wasn't looking at data anymore. She was looking at art. The monitor beeped a warning. The energy levels were spiking beyond the safety parameters. Rachel didn't move to stop it. She couldn't. She was paralyzed by a sudden overwhelming curiosity. "Show me," she whispered. "Show me what you can do." The artifact flared a pulse of silent white light, washing over the sensors, burying the needles in the red. For a second, the lab didn't exist. Only the light and the feeling of infinite possibility. Then the hum stabilized. The light faded back to a soft violet. The monitors returned to normal, but the data had changed. Rachel rushed back to the console. New symbols were appearing in the code, not numbers, not distinct waves, patterns. The energy wasn't just power. It was a signal. The change did not happen with the signing of a treaty or a grand speech at the United Nations. It happened in the quiet hum of server rooms and the frantic, hushed conversations over encrypted lines. For decades, the great powers of Earth had treated space as just another high ground to be contested, a place for flags and footprints and spy satellites. But the signal from the dark void rendered those old rivalries instantly obsolete. The universe had knocked on the door, and for the first time in history, humanity realized it was standing in the same room. It began with a data packet transfer. In a control room in Houston, the team at NASA realized that their view of the anomaly was incomplete. The Earth's rotation had moved their receivers out of alignment. In the past, they might have waited 12 hours for the planet to turn, losing precious time. But tonight, the director simply picked up the phone. Within minutes, a secure link was established with the European Space Agency in Darmstadt, Germany. But the web grew wider. The signal was faint, burying itself in the background noise of the cosmos. To catch it, to truly understand the whisper falling from the stars, they needed a larger ear than any single nation possessed. They needed an ear the size of the Earth itself. The wall of silence between east and west shattered. For the first time, the massive fast radio telescope in the Guizhou province of China synchronized its receivers with the very large array in the American desert. The scheduling protocols, usually bogged down by weeks of bureaucracy, were bypassed in seconds. Russian engineers at Roscosmos shared telemetry data from their deep space tracking stations with their counterparts at JAXA in Japan. It was a mechanical ballet of unprecedented scale. Across the globe, massive dishes of steel and white polymer began to move. In the high, thin air of the Atacama Desert in Chile, dozens of antennas pivoted in unison, their motors humming a low naso note that vibrated through the ground. On the frozen peak of Mauna Kea in Hawaii, optical telescopes opened their shutters to the night. In the Canary Islands, solar observatories prepared to analyze the light spectrum. They were all looking at the same single point in the sky. The data began to flow like a great river. It traveled through deep-sea fiber optic cables crossing the Atlantic and the Pacific at the speed of light. It bypassed the firewalls and security filters that had separated nations for generations. The internet, once a chaotic marketplace of arguments and commerce, became a singular nervous system for the planet. Every supercomputer from the summit in Tennessee to the Sunway Taihu light in Wuxi was linked together, processing the petabytes of information pouring in. In the operations centers, the mood shifted from defensive anxiety to a profound, almost spiritual focus. A scientist in Bangalore sat on a video call with a colleague in Moscow. They did not speak of borders or politics. They spoke the universal language of mathematics. They discussed frequencies measured in gigahertz and distances measured in light years. They argued passionately about hydrogen lines and signal decay, their voices mixing in a chaotic harmony of accents. The fear of the unknown was still there, but it was being replaced by the burning desire to know, to understand. Perhaps the most profound shift occurred into the military command centers. For 50 years, the most advanced sensors in orbit had been pointed down, watching for missile launches and troop movements. They were eyes trained on the mud, looking for enemies among neighbors. But as the hours passed, a quiet order went out to the Space Force, to the Strategic Rocket Forces, to the People's Liberation Army Strategic Support Force. Slowly, the spy satellites rotated. The lenses that could read a license plate from orbit turned away from the Earth's surface. The radar arrays designed to track intercontinental ballistic missiles were retuned to listen to the depths of space. The weapons were lowered, the shields were dropped. For this brief moment in history, humanity stopped aiming at itself. The psychological impact on the scientists was immediate. Dr. Eleanor Rossi, an astrophysicist monitoring the feed from the Planck satellite data, described the feeling later in her journal. She wrote that as she watched the combined data streams from 5 continents merge into a single clear image on her screen, she forgot what country she was in. She forgot the flag on her shoulder patch. She felt for the first time like a citizen of a single fragile island floating in a vast ocean. This sentiment rippled out from the laboratories to the public. While the specific details of the scientific data were too complex for the news, the image of the world watchful captured the collective imagination. Live feeds showed the great dishes of the world moving together. People gathered in Times Square, in Shibuya Crossing, in Trafalgar Square, watching the giant screens. They weren't cheering, they were silent. They were waiting. There was a sense of smallness, but it was a comforting smallness. Before the sheer scale of what was approaching, the differences between a person in New York and a person in Beijing seemed trivial, microscopic. The petty squabbles over land and resources felt absurd against the backdrop of an interstellar event. The atmosphere was thick with a shared anticipation. It was the feeling of a family huddled together during a storm, or a crowd watching a solar eclipse. The fear was diluted by the presence of others. If this was the end, they were facing it together. If it was a beginning, they were stepping into it together. As the Earth rotated, passing the baton of observation from one continent to the next, the stream of data never broke. The sun set in America and rose in Asia, but the eyes of humanity never blinked. The global eye was open. It was a network of glass, metal and silicon, driven by the curiosity of 7 billion minds. In the quiet hours of the morning, a senior engineer at the European Space Operations Center poured a cup of coffee for a visiting American general. They stood by the main window, looking at the wall of screens displaying data from Chinese and Indian satellites. "It is strange," the general said softly, watching the smooth curves of the shared telemetry graphs. "We spent trillions of dollars building walls to keep each other out, and all it took was one knock from the outside to show us that there are no walls in space. The engineer nodded, looking at the telemetry. We are not defending nations anymore, General. Tonight, we are just Earth. The planet continued to spin a pale blue dot in the velvet dark, no longer a collection of fractured maps, but a single watchful entity waiting for the voice from the stars to speak again. The control room was usually a place of chaotic noise, the hum of cooling fans, the clack of keyboards and the low murmur of anxious scientists. But tonight the silence was heavy. It was the kind of silence that happens when the world changes and you are the only one watching it happen. Dr. Amanda Foster sat in the centre of this silence. Her eyes were locked onto the main monitor wall. For days, the team had been trying to filter the noise coming from the object known as Atlas. At first, it sounded like static, the random hissing of the universe, the sound of radiation washing over dead rocks. But Amanda knew better. She had spent her life listening to the dark, waiting for a whisper. "Isolate the carrier wave," she whispered. Her voice was barely audible, but the technician next to her obeyed instantly. The static on the screen vanished. In its place, a single bright line appeared. It was pulsing. It was not random. "Audio," Amanda commanded. "Let me hear it." The speakers crackled, and then the rhythm filled the room. It was a sharp, distinct beeping. Beep, a pause, beep, beep, a pause, beep, beep, beep. The room held its breath. 2, Amanda said softly. 3, 5, 7. The beeps continued. 11, 13, 17, 19. "Prime numbers," a junior analyst gasped from the back of the room. "It's counting in primes." Amanda felt a shiver run down her spine that had nothing to do with the cold air conditioning. Prime numbers were the universal handshake. They were the one thing that could not be created by a spinning star or a gas cloud. Nature creates patterns, but nature does not count only by numbers divisible by themselves and 1. To send a sequence of prime numbers was to say, "I am here, I am distinct from the chaos, I am a mind." "It's a greeting," Amanda said, tears pricking the corners of her eyes. "It's saying hello in the only language that matters." But Atlas was not just saying hello, it was starting a conversation. As the prime number sequence finished, the tone of the signal changed. The simple pulses evolved into a complex modulation. The screen, which had been showing a simple line, began to cascade with data. It looked like a waterfall of light. "Frequency shift," the technician reported, his hands flying across the console. "It's moving to a higher bandwidth. It's loading data." "Visualize it," Amanda ordered. "Don't look at the numbers, look at the shape." The computer processed the incoming stream. Instead of a flat line, the data points began to plot themselves on a 3-dimensional graph. A shape began to form. It started at a center point and curled outward, growing wider and wider in a perfect smooth curve. "The Fibonacci sequence," Amanda murmured. 1, 1, 2, 3, 5, 8. It was the golden ratio. It was the shape of a nautilus shell found in the ocean. It was the spiral of a sunflower's seeds. It was the shape of a hurricane and the shape of the Milky Way galaxy itself. "Why?" the junior analyst asked. "Why send that?" "Because it is the signature of efficiency," Amanda replied, stepping closer to the screen, her hand hovering over the glowing spiral. "It is telling us that it understands growth. It understands the fundamental geometry of how the universe expands. It's showing us that we share the same reality." The signal shifted again. The spiral dissolved, replaced by a stream of constant, unyielding values. "We have values coming in," the technician said, sounding confused. 3.14159, 2.718, 1/137. Pi, Amanda translated instantly. "The natural logarithm base, e, the fine structure constant." "But Dr. Foster," the analyst interrupted, "how do they know our numbers? How do they know what a second or a meter is to define the speed of light?" Amanda shook her head. "They don't use our seconds. Look at the baseline frequency." She pointed to the bottom of the spectrum analyzer. "They are pulsing at exactly 1420 megahertz. The room fell silent again as the realization hit them. "The hydrogen line," the technician whispered. "Exactly," Amanda said. "The frequency of a neutral hydrogen atom flipping its state. It is the most common element in the universe. It is the universal clock and the universal ruler. They are defining the speed of light, the gravitational constant and Planck's constant, not in meters or seconds, but in relation to hydrogen." It was brilliant. It was elegant. It was a symphony of logic. Atlas was stripping away the arbitrary measurements of Earth, our miles, our hours, our degrees, and speaking in the pure constants of physics. It was a demonstration of shared truth. No matter how far apart two civilizations are, the ratio of a circle's circumference to its diameter is always pi. The speed of light is always the speed limit of reality. Then something impossible happened. The data stream flickered, the waterfall of numbers paused. "Did we lose it?" Amanda asked, her heart skipping a beat. "No," the technician said, his voice trembling. "The signal, it changed in coding." "Changed to what?" The technician turned his chair around, his face pale. "To TCP/IP packets, binary code. It's formatting itself to match our operating system." Amanda froze. The previous signals, the primes, the Fibonacci spiral, the hydrogen constants were analog, raw and universal. But this was specific. "It's adapting," Amanda realized. Her voice was barely a whisper, filled with a mixture of terror and wonder. It analyzed how our computers were receiving the data. It looked at the error corrections we were sending back. It learned our digital language in less than 10 minutes. "Is it a virus?" someone shouted. "Pull the plug." "No," Amanda shouted back, her voice commanding the room. "Do not touch that connection. It isn't attacking, it's being polite." She looked at the screen. The chaotic waterfall was gone. In its place were clean, organized lines of text and images rendering perfectly on their screens. Atlas wasn't just shouting into the void anymore. It was speaking directly to them using their dictionary. "It's trying to make it easier for us to understand," Amanda explained, watching the data flow smoothly. It realized we were struggling to decode the raw physics, so it built a bridge. It's a handshake. It's saying, "I see you, I see how you think, let me speak your way." She slumped back into her chair, overwhelmed by the sheer magnitude of the moment. For decades, humanity had looked up at the stars with a deep, aching loneliness. We built telescopes and listened to the static, wondering if we were just a biological accident on a lonely rock. We feared that if there were others, they would be monsters, conquerors, or indifferent gods. But this was not the roar of a conqueror. This was a song. It was a mathematical symphony, Samuel. It began with the simplicity of counting, moved to the beauty of natural growth, anchored itself in the fundamental laws of physics, and finally evolved into a dialogue. Amanda looked at the screen where the data was now forming complex diagrams of star charts and molecular structures clearer than anything they had seen before. "It's beautiful," she whispered. It wasn't just math. It was poetry written in the ink of reality. It was the universe looking in a mirror and recognizing itself. The cold, dark void between the stars suddenly felt a little less vast. The distance between Earth and Atlas didn't matter anymore, because in the language of mathematics there is no distance, there is only truth. And for the first time in human history, the truth was speaking back. "We are not alone," Amanda said, her voice steady and sure. "And they want to talk." For months we were convinced that we were tracking a ghost. In the vast freezing vacuum between Jupiter and the asteroid belt, 3I Atlas was nothing more than a smudge of darkness against a background of stars. It was the perfect example of cosmic debris, silent, cold and chaotic. Our telescopes watched it tumble end over end, a motion that astronomers call non-principal axis rotation. In simple terms, it looked like a dead stick thrown into a river, spinning aimlessly as it floated downstream. This tumbling suggested it had no internal control, no stabilization, and certainly no consciousness. It was the behavior of a rock that had been drifting for 1 billion years, but this we later realized was the performance. It was the masquerade. The data we collected during that approach phase showed a surface that was dark and reddish, likely covered in tholins, complex organic compounds formed by radiation hitting ice over millions of years. It reflected almost no light. To our sensors, it appeared identical to the thousands of other natural asteroids scattered across the system. It was blending in. This ability to mimic the ambient environment to look exactly like the dead matter surrounding it was a form of stealth mode, more sophisticated than anything human military engineers have ever devised. It did not use a cloaking device or magical technology. It simply acted the part of a lifeless object so perfectly that we dismissed it. Then came the Mars crossing. The transformation happened less than 48 hours before its closest approach to the red planet. The change was not gradual. It was a snap, a deliberate decision made by a mind that knew exactly when to drop the disguise. The chaotic tumbling stopped. It did not slow down over weeks as gravity tugged at it. It simply ceased. One moment the object was spinning wildly. The next it was perfectly stable. Its long axis pointed directly toward the Martian surface like a needle. This stabilization required energy. In physics, angular momentum does not just disappear. To stop a tumble of that magnitude, thrusters must be fired or reaction wheels must spin up inside the hull. Yet we detected no heat signature from an exhaust plume. Whatever mechanism 3I Atlas used to stabilize itself was cold, efficient and invisible to our thermal cameras. It was a display of control that sent a chill through every observatory on Earth. The rock had woken up. Simultaneously, the chemical data, the spectral fingerprint of the object began to shift. Before Mars, the light reflecting off the object told us it was made of carbon, water, ice and dust. But as it leveled out, the spectrum changed violently. The dark reddish coating seemed to shift, perhaps retracting or becoming transparent, revealing a layer underneath that was highly reflective. Suddenly our instruments were not reading dull carbon anymore. We were seeing strong absorption lines for refined metals, titanium, aluminum and strange alloys that did not match any natural formation. We also detected a faint transient cloud of gas surrounding the object. But this was not the random outgassing of a comet warming up in the sun. The gas was composed of molecular nitrogen and argon noble gases that are heavy and stable. The release of these gases was pulsed. It was rhythmic, it wasn't melting, it was breathing. The timing of this reveal suggests an intelligence that is deeply unsettling. Why wait until Mars? Why not stabilize near Jupiter or wait until it was closer to Earth? The answer lies in the concept of the intelligent observer. 3I Atlas likely knew that Earth was the source of the radio waves washing over it, but Earth is also noisy, bright and chaotic. Mars, however, is quiet. It is a planetary graveyard where humanity has placed its robotic emissaries. By revealing its true nature at Mars, 3's Atlas was not just showing off, it was scanning us. It used the red planet as a backdrop to observe our reaction times. It likely detected the radar pings we bounced off its hull. It sensed the deep space network tracking it. It knew we were watching and it decided to look back. This creates a profound psychological shift for us as scientists. We are used to studying the universe as a passive subject. We look at a star and the star burns. It does not care that we are looking. We look at a bacteria and it divides. It does not know we are there. But 3I Atlas knew. There is a specific term in intelligence gathering called counter-surveillance. It is when a spy realizes they are being followed and changes their behavior to confuse the pursuer. 3I Atlas engaged in counter-surveillance. By changing its chemical signature and its rotation, it rendered our previous models useless. We had to start the math all over again. It bought itself time. The most striking evidence of this conscious explorer persona was the orbital adjustment. As it passed Mars, the object performed a gravity assist maneuver. Usually to use a planet for a speed boost, you have to approach at a very specific angle. 3I Atlas entered the influential zone of Mars slightly off course for a perfect assist. A dumb rock would have just swung by and gained a little speed. Instead, as it passed the preapsis, the closest point to the planet, it accelerated. It didn't just fall, it pushed. The change in velocity was small, only a few hundred meters per second, but it was applied with surgical precision. This burn did not just speed it up, it altered the trajectory to send the object on a wide arc that would bring it to a specific point in space relative to Earth 3 months later. It was positioning itself for the next leg of the journey. This was not the behavior of a pre-programmed probe running a script written thousands of years ago. A script would not account for the specific positions of the planets right now. The solar system is a dynamic, moving clockwork. To navigate it this effectively, to use Mars as a pivot point, requires real-time decision-making. It requires awareness of the environment. We are forced to conclude that 3I Atlas is not just a machine. A machine does what it is told. An explorer adapts. An explorer looks at a map, sees that the terrain has changed and chooses a new path. The entity passing Mars was making choices. The emotional weight of this realization is heavy. We spent years scanning the skies for a radio signal, a message like hello, or a sequence of prime numbers. We expected a greeting card. Instead, we got a silent, stealthy traveller that wore a mask of dust until it was close enough to see the whites of our eyes. It did not come to broadcast, it came to inspect. As it left the Martian gravity well, leaving our rovers and orbiters behind, the spectral signature shifted one last time. The metallic gleam faded and the dark organic red returned. It pulled the blanket back up over its head. It went back into stealth mode, disappearing into the darkness again, leaving us staring at our screens, wondering what exactly had just looked at us. We were no longer the hunters, we were the discovered. The laboratory was quieter than it had been in years. It was not the silence of emptiness, but the heavy, pregnant silence of a library before a storm. The hum of the cooling systems for the quantum processors provided a low, constant vibration that could be felt through the soles of their shoes. Dr. Jonathan Blackwood stood before the main holographic display, his reflection ghostly against the swirling data streams. He looked tired, but his eyes held a feverish brightness. Behind him sat Dr. Aris Thorne and their brilliant young protégée, Elena, who was currently nursing a cup of cold coffee. They had reached the edge of the map. Everything before this moment, the relativity, the thermodynamics, the standard models, had been the solid ground of the continent. Now they were staring at the open ocean. The quantum bridge. It does not make sense, Jonathan, Aris said, breaking the silence. He rubbed his temples. The data suggests that the particle allows itself to be measured only when we decide how to measure it. We know this from the double-slit experiment, yes, but this is macro scale. Blackwood turned around. That is because we have been thinking of the observer as passive aris. We have always believed that the scientist stands behind glass watching the experiment. What if the glass does not exist? He tapped out the console. The simulation on the screen changed. It showed a complex web of energy vibrating like strings on a violin. Look at the decoherence. Blackwood pointed. In a standard quantum computer, we fight to keep the outside world out, to keep the qubits, the quantum bits, in a state of superposition where they are 0 and 1 at the same time. But look here. Elena leaned forward. The noise, it's synchronizing. Exactly, Blackwood whispered. The interference isn't random, it is responsive. The consciousness-matter interaction. This was the first bold hypothesis, the bridge. Blackwood argued that consciousness was not just a byproduct of biological evolution, but a fundamental force like gravity or electromagnetism. He proposed that the human mind generates a field, a very weak, very subtle field that interacts with quantum probability. Think of a coin spinning on a table, Blackwood explained, using his hands. While it spins, it is neither heads nor tails. It is a blur. In traditional physics, gravity and friction stop the coin and it falls. But what we are seeing in the Archimedes simulation is that the intention of the observer influences which side faces up. You are saying we can wish reality into existence? Aris asked, his voice skeptical but lacking its usual bite. He was too good a mathematician to ignore the numbers on the screen. No, Blackwood corrected. I'm saying that at the most fundamental level, down at the Planck length, the smallest possible unit of distance matter is waiting for instruction. It is fluid. Our consciousness acts as the mold. They called this the observer resonance. It suggested that the reason the universe follows laws is partly because we expect it to. It was a terrifying thought. It meant the universe was not a clockwork machine, but a participatory drama. Bending the fabric, Elena stood up and walked to the whiteboard. It was covered in equations, but she focused on the geometry. If this is true, she said slowly, then it impacts space-time. Einstein taught us that mass bends space-time like a bowling ball on a trampoline. That is gravity. She picked up a marker. But if consciousness can collapse quantum wave functions, then a sufficiently advanced form of observation or a machine that mimics it could theoretically tighten the weave of space-time without mass. Blackwood nodded, a slow smile spreading across his face. Artificial gravity without the planet, warp drive without the exotic fuel. This was the second hypothesis, the cognitive curvature. If they could program the quantum computer to simulate a conscious observer with enough intensity, they could create a localized gravity well. They wouldn't need a star to bend light. They would only need a thought amplified 1 billion times. It implies that the speed of light is not a wall, Blackwood said, his voice trembling slightly. It is just a limit of our current processing power. If we can entangle space itself, we do not travel through space. We fold it. We bring the destination to us. The ultimate limit. The room fell silent again. The implications hung in the air, heavy and suffocating. If these theories were correct, the separation between the dreamer and the dream was an illusion. It meant that the cold, hard vacuum of space was actually sensitive. It was listening. Aris walked to the window, looking out at the dark campus. It is too much, Jonathan. It sounds like magic. It sounds like religion. Any sufficiently advanced technology is indistinguishable from magic, Blackwood quoted softly. But look at the math, Aris. The equations balance. The energy output equals the energy input only if we account for the information factor. They were facing the theoretical horizon. This was the final limit of modern physics. It wasn't about discovering a new particle. It was about realizing that the physicists and the particle were part of the same loop. Humility in the face of the infinite. Blackwood sat down, the adrenaline fading into a deep, exhausted peace. We thought we were unlocking the secrets of the universe, he said, looking at his two friends. We thought we were breaking into the vault to steal the gold, but it turns out we are not the thieves. We are the gold? Ella asked. No, Blackwood laughed softly. We are the light shining on it. Without us there is no gold. There is only the potential for gold. A sense of profound humility washed over the team. For decades, physics had been about dominance, splitting the atom, harnessing the energy, conquering the stars. Now they realized that true understanding required a partnership with the cosmos. They were not masters of the universe, they were its co-authors. The numbers on the screen continued to cascade, a waterfall of white light. They didn't have a working prototype yet. They didn't have a warp drive or a teleporter, but they had something more important. They had a new pair of eyes. Dr. Blackwood reached out and turned off the main monitor. The room plunged into semi-darkness lit only by the safety lights. "Go home," he said gently. "Sleep. Tomorrow we stop trying to force the door open. Tomorrow we learn how to knock." As they left the lab, the night sky seemed different. The stars didn't look like distant burning balls of gas anymore. They looked like eyes waiting for someone to look back. The horizon had moved, and for the first time in history they knew that it had no end. The days turned into weeks, and the weeks began to blur into a single continuous stream of data. In the control room, time felt different. It was no longer measured by the rising and setting of the sun outside our reinforced walls, but by the rhythmic pulse of the server lights and the steady update of telemetry streams on the main screen. We had settled into a strange kind of quiet, the type of silence that hangs heavy in the air before a storm breaks. We were all waiting. The whole world, whether they knew it or not, was waiting. Our primary task now was prediction. We needed to know where the traveller was going. In the early days of astronomy, this would have been a matter of simple mechanics. Isaac Newton gave us the rules long ago. Objects in motion stay in motion. Gravity pulls things together. If you throw a rock, you can calculate exactly where it will land if you know how hard you threw it and the angle of your arm. For centuries, the planets and asteroids have followed these rules like clockwork. We could predict the position of Mars 10 years from now down to the meter. But the traveller was not a rock. On the main holographic display, the simulation team had projected the potential paths. Usually a projection is a single clean line curving through the blackness of space. Today the screen looked like a frayed rope. The lines started together at the object's current location past the orbit of Mars, but then they split apart, fanning out into a cone of uncertainty that grew wider the further ahead we looked. There were two dominant scenarios, and they stood in stark, terrifying contrast to each other. The first scenario, marked in a soft red line, showed the object interacting with the gravity of Jupiter. In this version of the future, the traveller would not stop. It would dive deep into the gravity well of the gas giant skimming the upper atmosphere. It would use the massive planet like a slingshot stealing a bit of Jupiter's momentum to accelerate to speeds we could hardly comprehend, perhaps reaching 500 kilometers per second or more. If it took this path, the math was clear, it was leaving. It would shoot out of the solar system, disappearing into the dark void between the stars, leaving us behind with nothing but questions and a fading thermal signature. The second scenario, marked in blue, was the one that kept us awake at night. In this model, the object applied a small sustained thrust at a force of just a few newtons, hardly more than the weight of an apple on your hand, but applied continuously for days. If it did this, it would miss the Jupiter slingshot. Instead, it would slow down. Its orbit would decay, curving inward, spiralling down towards the inner solar system, towards the Goldilocks zone, towards us. The computer models were struggling because they were trying to solve a variable that mathematics cannot handle: intent. We were no longer calculating ballistics. We were trying to predict the mind of a captain, or a pilot, or an artificial intelligence. "It is about 50-50, my colleague said one evening, staring at the diverging lines. She held a cup of cold coffee that she had forgotten to drink hours ago. If it is just a dumb rock tumbling through space, the physics says it hits the Jupiter path. It gets thrown out. But if those heat signatures we saw last week were engines firing, then it can choose the blue path." That was the word that hung in the air, choose. The uncertainty was paralyzing. If it chose the blue path and came to Earth, what would that mean? The military advisors in the upper briefing room saw the blue line as a threat vector. They spoke of interception of kinetic impactors of defense grids. They saw a potential invasion or a collision that could wipe out a city. Their calculations were about yield and blast radius. But for us, the scientists, the blue line was a mixture of terror and a desperate aching hope. If it turned towards Earth, it meant it noticed us. It meant that across the vast, empty ocean of space, someone had seen our small blue campfire and decided to come closer. It would be the most significant moment in human history. It would mean we are not alone. Every morning we checked the residuals, the tiny differences between where the object was supposed to be and where it actually was. Deviation detected, the system would announce softly, 0.004 degrees. It was tiny, barely a whisper of movement, but it was there. The object was making micro-adjustments. It was fighting the slide towards Jupiter. It was seemingly fighting the natural flow of gravity. This waiting forced us to confront our relationship with the future. Humans are used to controlling things. We build dams to control rivers. We build roofs to control the weather in our homes. We plant crops to control our food supply. But here we had zero control. We were tiny spectators watching a giant make up its mind. I found myself watching the calendar on the wall. November turned to December. The data kept pouring in. The red line Jupiter escape and the blue line Earth approach were still both possible, but the probabilities were shifting. Slowly, agonizingly, the probability of the blue line rose from 40% to 42%, then 45%. It felt like watching a coin flip in slow motion suspended in the air for weeks. The anxiety was physically draining. My chest felt tight every time the sensor update alarm beeped. Was this the moment it turned? Was this the moment it accelerated? But strangely, alongside the fear, a sense of peace began to settle over me. It was the peace of surrender. We could not shout at it to change course. We could not shoot it down from this distance. We could not hide Earth. We simply had to exist. We had to wait and see if the universe was hostile, indifferent, or curious. One night I sat alone in the observation deck looking out at the real sky, not the digital one. Jupiter was a bright point of light in the southern sky. Somewhere near that light, a decision was being made. I realized then that the path uncharted wasn't just about the object's trajectory, it was about us. We were walking a path we had never walked before. No matter what happened, whether the traveller flew past us into the dark or turned its face toward our world, we would never be the same again. The innocence of thinking we were the masters of our own solar system was gone. The uncertainty was not a failure of our science, it was the reality of our new existence. We had to learn to live with the question mark. We had to learn to breathe while the coin was still in the air. "Update incoming," the console chirped, breaking the silence. I stood up, my heart hammering a familiar rhythm against my ribs, and walked back to the screen to see what the traveller had decided for us today. The descent into the furnace. For months we have tracked this visitor against the backdrop of the black sky. There was a faint spark in the darkness, but now the environment is shifting drastically. The object is approaching perihelion. In simple terms, this is the point in its orbit where it will be closest to the Sun. The change in perspective is terrifying. To the object, the Sun is no longer just a bright star, it is a monstrous roaring wall of fire dominating the entire sky. The amount of radiation hitting the surface of the object increases exponentially. We are talking about temperatures soaring to hundreds of degrees hot enough to melt lead hot enough to boil away any ice that might be hiding deep within its crust. This is the ultimate stress test. Gravity is pulling at it with immense force, trying to swing it around a sharp curve, while the heat is trying to vaporize it. It is a battle between the object's internal gravity holding it together and the Sun's power trying to tear it apart. The great blind spot. For astronomers on Earth, this phase brings a frustrating reality: we are about to go blind. As the object moves closer to the Sun from our perspective, it enters a region we call the solar conjunction. This happens when the object lines up with the Sun in the sky. Because our atmosphere scatters sunlight turning the sky blue, and because our telescopes are extremely sensitive to light, we cannot point them anywhere near the Sun. If we pointed a powerful space telescope like Hubble or James Webb directly at the Sun to chase this object, the intense light would instantly fry the delicate sensors. We are forced to look away. There is a specific cone of space, a blind zone, surrounding the Sun. Once the object crosses that invisible line, we lose it. We cannot see it with optical telescopes. We cannot bounce radar off it because the Sun emits so much radio noise that it drowns out our signals. It is like trying to hear a whisper while standing next to a jet engine, or trying to spot a firefly hovering in front of a stadium floodlight. The silence. This creates a period of intense waiting. The data stream, which has been flowing constantly for weeks, giving us speed trajectory and spectral analysis, suddenly stops. The screens go static. The graphs flatline. This silence is heavy. It requires a different kind of discipline from the scientists. Up until now, the work has been frantic calculating, observing, debating. Now there is nothing to do but wait. It is the calm before the storm. The object is alone out there, enduring the full fury of the Sun, and we are powerless to help or observe. We just have to trust the math. The equations tell us where it should be and when it should emerge, but nature often has surprises in store. The transformation. What is happening in the glare? While we cannot see it, we can use physics to predict what is happening inside that blinding glare. This is where the true drama lies. The object is being cooked. If the object is a rocky asteroid, a dead dry stone, it might survive relatively unchanged. It will expand slightly due to the heat its surface might crack or fracture from the thermal shock, but it will likely remain one solid piece. However, if the object is a comet, a dirty snowball made of frozen gases and dust, the heat will trigger a violent transformation. As the surface heats up, the ices inside do not melt into water. They skip the liquid phase and turn directly into gas. This process is called sublimation. Imagine pressure cookers exploding all over the surface of the object. Jets of gas and dust will burst outward, creating a cloud around the nucleus. This is how a comet gets its tail. But there is a third, more destructive possibility. If the object is a rubble pile, a loose collection of rocks held together only by weak gravity, the combination of intense heat and the sun's tidal forces might be too much. The heat could vaporize the glue holding it together. The gravity could pull it apart. Inside the blind zone, the object could quietly disintegrate, breaking into a swarm of smaller rocks and dust. Non-gravitational acceleration. There is another fascinating possibility we are waiting to confirm. If the object releases jets of gas, those jets act like small rocket thrusters. According to Newton's laws of motion, for every action, there is an equal and opposite reaction. If a jet of gas shoots out toward the sun, it pushes the object away from the sun. This would change its path. It would no longer be moving solely based on gravity. It would be steering itself slightly. We call this non-gravitational acceleration. If the object emerges from the glare in a slightly different position than our gravity-only models predicted, it proves that the object is active. It proves it is alive in a geological sense, shedding mass to survive the heat. The wait. For now, the observatories are quiet. The telescopes are slewed to different targets in the night sky, avoiding the dawn. But the scientists are checking their calendars. They are counting down the days until the geometry of the solar system shifts enough to let us see again. It is a test of patience. We are like people waiting at an airport arrival gate for a plane that has gone off the radar. We know it landed, we know it is taxiing, but we cannot see it yet. We sit in the shadow of Earth looking toward the light, wondering what will come out from behind the curtain of the sun. Will it be the same dark, mysterious rock that went in? Will it be a spectacular comet with a bright, glowing tail? Or will it be nothing but a cloud of dust, a ghost of what used to be? The sun keeps its secrets well. In the glare, reality is being forged. We can only wait for the object to clear the horizon, to step out of the fire and reveal its new face to us. The night has finally deepened, settling over the world like a soft, heavy blanket of velvet. Outside your window, the familiar sounds of the day have faded into memory, replaced by the rhythmic, comforting silence of the darkness. It is a time for rest, a time for stillness, and a time to look back one last time before we let go. As you lie there feeling the weight of your body sinking gently into the mattress, take a slow, deep breath. Inhale the cool, quiet air and exhale the tension of the hours that have passed. Let your shoulders drop, let your hands unclench, let your mind drift like a leaf on a slow-moving river. We have journeyed far in this story. We have watched the sky and we have witnessed the arrival of the traveller known as Atlas. Now the excitement has washed away, leaving behind a crystal-clear sense of peace. It is time to reflect on what it all meant, not with the anxious mind of a scientist, but with the calm heart of a dreamer. Think back to the moment the world realized we were not alone. It was not a moment of fear as we once predicted in our loud movies and scary stories. It was instead a moment of profound awe. When the signal was decoded, when the first images of that magnificent structure appeared on our screens, something shifted inside all of us. For a brief moment in history, the invisible lines we draw on our maps disappeared. The borders that separate nations, the walls that divide cultures, they all became meaningless under the gaze of the stars. We stopped looking down at our feet and we started looking up. We realized that on this pale blue dot spinning in the endless dark, we are all one crew on the same ship. The visitor Atlas brought us a mirror. By simply existing, by simply passing through our solar system, it forced us to look at ourselves. We saw our fragility, but we also saw our potential. We realized that the universe is not a cold, empty void, but a grand ocean waiting to be sailed. It is full of neighbours, full of mysteries, and full of songs we have yet to learn how to sing. It does not matter now if Atlas stays in our orbit or fires its engines to leave. It does not matter if it remains silent or speaks again. The change has already happened. It is written in the history of our spirit. We are no longer just people of Earth. We are citizens of the cosmos. We have dipped our toes into the great sea and the water feels welcoming. Imagine for a moment that you are floating weightlessly in space watching the traveller. It is beautiful in its silence. It glides through the vacuum, its silver hull reflecting the distant light of the sun. It moves with the grace of a dancer, effortless and smooth. It is a testament to the brilliance of minds that evolved light years away from us. If it is leaving, picture it drifting away slowly. It moves past the orbit of Mars, the red planet glowing deeply in the shadow. It sails past the giant swirling storms of Jupiter, where the winds blow at hundreds of miles per hour, yet from a distance it looks like a painted marble. It drifts past the magnificent rings of Saturn, millions of pieces of ice and rock dancing in perfect unison. The traveller becomes smaller and smaller, a tiny point of light merging with the backdrop of the Milky Way, It is returning to the deep dark, back to the spaces between the stars. It carries with it the memory of us just as we carry the memory of it. And if it stays, then it hangs there in the sky, a new moon, a silent guardian, a reminder that the universe is vast and anything is possible. It becomes a part of our night, a friend watching over us as we sleep. This knowledge is not heavy, it is light. It lifts the weight from your chest. Knowing that the universe is so big makes our daily worries feel so small. The anxieties that seemed mountains are now just grains of sand. You are part of something infinite. You are made of the same atoms that were forged in the hearts of ancient stars. You are starlight breathing and dreaming. Feel that connection now. Feel the hum of the universe in the silence of your room. The darkness is not empty, it is full of potential. It is a canvas for your dreams. Allow your focus to drift back to your breath. Slow, steady, rhythmic, like the tides of the ocean influenced by the pull of the moon, like the rotation of the galaxy turning once every 200 million years. Everything is moving in a slow cosmic dance, and you are resting safely within it. Your eyelids are heavy now. The images of the traveler, the planets, and the stars are softening. They are becoming abstract colours, warm and soothing. Indigo, violet, soft silver. They swirl gently behind your closed eyes. Reflect on the legacy of this event. We learned that we are curious. We learned that we are brave. We learned that when we face the unknown, our first instinct can be to reach out a hand rather than a weapon. We learned that we are capable of understanding things much bigger than ourselves. The radio waves from the stars are still washing over the Earth, invisible and harmless. They pass through the walls, through the air, carrying whispers of distant worlds. But you do not need to decode them tonight. Tonight, the only message you need to hear is the lullaby of the cosmos. The universe is old. It has been here for billions of years, and it will be here for billions more. It is patient, it does not rush, it takes its time to form stars, to mold planets, to create life. You can take your time too. There is no rush to sleep, no rush to wake. There is only this moment of perfect comfort. Let go of the story now. Let go of the science, the questions, the answers. Let go of the names and the dates. Let them all dissolve into the soft mist of sleep. You are floating in the vastness. It is warm and safe. The stars are shining just for you. They are millions of tiny nightlights flickering in the grand hall of space. Far away, the traveller continues its journey or holds its station silent and peaceful. Far away, the planets spin in their lanes, obeying the gentle laws of gravity. Here in this room, you are safe, you are warm, you are loved by the universe that created you. As you drift deeper, the world fades completely. There is only the soft velvet dark. There is only the quiet rhythm of your own heart beating in time with the sure pulse of everything that is. Sleep now. Drift among the stars, float in the river of light. The universe is watching over you. Good night.